All right, question number 19. We have a figure on the right, shows a container that's going to be filled with water. Assume water is poured into the container at a constant rate, filled in 10 seconds. Assume horizontal sections are always circles. H of T is the depth of the water in the container over the time period. T is 0 to 10. I'm going to answer parts A through D. So part A, sketch a graph of the function H of T for 0 to 10 seconds. Based on the shape, it looks like it'll fill pretty fast, and then it'll slow down when it's going around this big old section, and then it'll speed back up. So this one looks like it's just slowly increasing. They don't match. This one looks like it's filling and then slows down and then fills up. So B probably looks the best out of the graphs presented. This one wants us to explain why the function is increasing. As you're putting water in, the height will always be going up. So the value of T is increasing. That's always going to usually be the case as we're going left to right, the x-axis. We're really focused on the y. Because we're always reading the graph left to right, depends on what's happening, if it's going up or down, so not the T. The derivative, H is always increasing, don't know that. We could tell. C is water is being added into the container at all times. That's going to be the best one because the height is increasing, and this one says the height of the container is increasing. And the height of the container isn't the water. The height of the water is increasing. All right, part C, describe the concavity. So if we look at this graph, unlike these where it's concave up and concave down, doesn't really look like there's anything. There's a part here that could be concave down, and then this little section over here could be concave up, but these linear parts don't really have concavity. So it says the function has no concavity, then it's concave down, no. So let me make this full screen. All right, it says no concavity, then concave down, no concavity, concave up, then no concavity, no inflection points. That could, none, then down, nothing really here, then up, then none. Okay, that looks like it could work. The other one says it's down from 0 to 5 and then up from 5 to 10. It's not really like this one. This one is, you can see the curvature. This one is just linear. You couldn't really tell up or down. So I wouldn't agree with that one. Concave up, 0 to 5, and we can see the first one is down. This one says concave down, 0 through 10. So A is probably going to be the best choice here. And then part 4, where does H prime, the derivative of H, have an absolute maximum? All right, this function is increasing. So it looks like there could be a maximum if they're looking for a minimum. We're usually at our endpoints. So it says it has, the derivative has an absolute maximum of t equals 0. That's not going to be the case. Derivative has an absolute maximum at t equals 0 and 5. Nothing with 0, I would believe. Derivative has an absolute maximum at 5 and 10. Have to look at that. Where is 5 happening? You can't even tell. About halfway. Wouldn't say that. And then D, absolute maximum at all points of the interval 0 to A, and B to 10, where A and B are real numbers. numbers. So if we use this interval, A would always be the maximum. And if we use this number B, 10 would always be the maximum. So yeah, this sounds good.